Okay, so let's go ahead and we're going to analyze limits to determine where vertical asymptotes are. Okay. And I'll say this once. We'll go into more detail in the next section next time on Wednesday's class. But let me just say, vertical asymptotes and holes arise from exclusions in the domain. So whenever you're looking for either vertical asymptotes or holes, you say, where are the boundaries of the domain of this function? And let's go explore those. This function's not defined where? At 3. So at 3, we will either have a vertical asymptote or a hole or both. We will see one example of a function that has both a vertical asymptote and a hole at the same location. That'll be kind of interesting. You may not have seen one of those before. So, what's happening at x equals 3? I don't know. Let's go find out. Okay? So, we're going to look at the limit as x approaches 3 of 2x over x minus 3. We're going to approach the problem in the domain. We can't plug in 3. Why? This function's not defined there. We're going to explore the area around that problem. But here's the thing. I'm trying to use my number 7 shortcut stuff on the previous page, and I can't do it because I can't generalize what's happening as x is approaching 3. So let's pick a direction of approach first. So let's approach it from the right. Okay? What is the numerator of this expression approaching? 6. The numerator is approaching 6. What's the denominator approaching? A very, very small but positive number. What is a positive number divided by an arbitrarily small positive number? You can use without any justification. You can say that equals plus infinity, or just infinity. What if we go the other way? We look at the limit as x approaches 3 from the left of 2x over x minus 3. Well, even though I'm approaching 3 from the left, I'm plugging in numbers like 2.9 or 2.99. What happens when I multiply that by 2? I get numbers that get close to what again in the numerator? 6. Divided by a very, very small but negative number. Positive quantity divided by an arbitrarily small negative number, no work is required, is negative infinity. Okay. I want to make something very clear here, folks. I've talked through the explanation of this in the air. If you wanted to give yourself some notes, you could do something like this. Draw an arrow and say that you got this because you had 6 over a small positive. But the thing that I don't want to have happen is I don't want this expression to show up equaling the math that you're doing. This is just the in-the-air justification that I'm giving for this problem that requires no work. Okay? Because it bothers me when people start writing 6 divided by 0.001 equals infinity. Well, it doesn't equal infinity. You can do 6 divided by 0.001. That equals, 6,000. Okay? So this is just the scratch work off to the side that's justifying this true statement here. Okay? All right. By the way, we don't have to say this, but what is the limit proper? Does not exist because the left-hand limit and the right-hand limit weren't equal. Okay. Now, what was the question? The question didn't ask us to compute limits. We had to compute them to answer the question. What was the question here? Yeah, where are the vertical asymptotes? Well, what did we find? We found when we explored this area, one or both or all of these limits came out to be infinity. So we have a vertical asymptote at x equals 3. Folks, don't just say there's an asymptote at 3. Please give me x equals 3 so I know that you know you're talking about a vertical line, not a horizontal one. Okay? So don't just say there's a vertical asymptote at 3. Say at x equals 3.